Myself, Megha Rathod. I am teaching maths in LP Savani Vidya Bhavan. Today we start chapter number 8. The name of the chapter number is quadrilaterals. In chapter number 8, quadrilaterals. The definition of the quadrilaterals is a figure formed by joining 4 points in an order such that no 3 of them are collinear is said to be a quadrilateral. This is the definition of quadrilateral and you have to learn properly. Here says that the 4 points join in order, but any 3 points is not collinear. So it is said to be quadrilateral. Now second point. Some terms related to quadrilaterals. Here give the figure and according to the figure we have to explain all the things. In a quadrilateral ABCD we have vertices. So you see in figure the points A, B, C, D are called the vertices of the quadrilateral ABCD. Sides. The line segment AB, BC, CD and DA are called the sides of the quadrilateral ABCD. In figure you see there are 4 sides AB, BC, CD and DA. Now next, diagonals. The line segment AC and BD are called the diagonals of the quadrilateral ABCD. Next, adjacent sides. 2 sides having a common endpoint are called adjacent sides in given figure AB, BC, BC, CD, CD, DA, DA, AB are 4 pairs of adjacent sides of the quadrilateral of ABCD. Now next, opposite sides. 2 sides having no common endpoint are called opposite sides. In the given figure, AB and CD and AD and BC are 2 pairs of opposite side of quadrilateral ABCD. Now you can see in the figure here AB opposite side DC and AD opposite side BC. We can see in the figure. Now next, consecutive angles. 2 angles of a quadrilateral having a common arm are called consecutive angles. In the given figure, angle A, angle B, angle C, angle C, angle D, and angle D, angle A are 4 pairs of consecutive angles. You see in the figure, here angle A, angle B, angle C, angle C, angle D, and angle D, angle A are consecutive angles. Now next, opposite angles. 2 angles of a quadrilateral having no common arm are called its opposite angles. In the given figure, angle A, angle C, angle B, angle D are 2 pairs of opposite angles of quadrilateral ABCD. Now you see in the figure, angle A and angle C, both angle have no common arm. Same thing, angle B and angle D, they have also no common arm. So both are opposite angles. Next, angle sum property of quadrilateral. Sum of all the 4 angles of a quadrilateral is 360. It means if ABCD is a quadrilateral, then we can write angle A plus angle B plus angle C plus angle D is equal to 360 degree. Same thing we learnt in full triangle. Angle sum property of triangle. Okay, sum of the 3 angles of the triangle is 180. Same thing here. The sum of the 4 angles of the quadrilateral is 360. Now, various type of quadrilaterals. First, parallelogram. A quadrilateral in which opposite sides parallel is called the parallelogram. In figure ABCD is a quadrilateral in which AB parallel CD and BC parallel AD. Thus, quadrilateral ABCD is a parallelogram. In the parallelogram, opposite sides are always parallel. So, this quadrilateral is called the parallelogram. Next, rhombus. A parallelogram having all sides equal is called the rhombus. A parallelogram having all sides equal is called the rhombus. In figure ABCD is a parallelogram in which AB is equal to BC is equal to CD is equal to DA, and AB parallel CD and AD parallel BC. Thus, parallelogram ABCD is a rhombus. Next, rectangle. A parallelogram in which each angle is equal 90 degree is called a rectangle. In figure ABCD, a parallelogram in which angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. AB parallel CD and AD parallel BC. Thus, parallelogram ABCD is a rectangle. Next, square. A rectangle having all sides equal is called a square. In rectangle, you see opposite sides are equal. But in square, all sides are equal. A rectangle having all sides are equal is called a square. In figure ABCD is a rectangle in which angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree. AB is equal to BC is equal to CD is equal to DA. Means all sides are equal. Thus, rectangle ABCD is a square. Next, trapezium. A quadrilateral having exactly one pair of parallel sides is called a trapezium. In figure ABCD is a trapezium in which AB parallel CD. Thus, ABCD is a trapezium. Next, isosceles trapezium. A trapezium having non-parallel sides are equal is said to be an isosceles trapezium. In figure ABCD is a trapezium in which AB parallel CD and AD is equal to BC. Thus, trapezium ABCD is isosceles trapezium. You learnt in triangle, isosceles triangle. In triangle, two sides are equal is called the isosceles triangle. Same thing here, isosceles trapezium. Here non-parallel sides are equal. This is called the isosceles trapezium. Now kite. A quadrilateral in which two pairs of adjacent sides are equal is called the kite. In figure ABCD is a quadrilateral in which AB is equal to AC and BC is equal to CD. Thus, quadrilateral ABCD is a kite. Now, some important notes we have to learn and explain. First, a square, rectangle and rhombus are all parallelograms. Square, rectangle and rhombus are all parallelograms. Next, square is a rectangle as well as a rhombus. Square is a rectangle as well as a rhombus. Next, a rectangle or a rhombus is not a square. We can say square is rectangle and rhombus, but rectangle and rhombus is not square. Next, a parallelogram is a trapezium. A parallelogram is a trapezium. Next, kite and trapezium are not parallelogram. This is the important notes. Now we discuss about properties of parallelogram. First, a diagonal of the parallelogram divides it into two congruent triangles. Diagonal of a parallelogram divides it into two congruent triangles. Next, in a parallelogram, opposite sides are equal. Next, in a parallelogram, opposite angles are equal. Next, the diagonals of parallelogram bisect each other, means equal two parts. Diagonals of the parallelogram bisect each other. If each pair of opposite sides of the quadrilateral is equal, then it is a parallelogram. Here you can see opposite side, pair of opposite sides of quadrilateral are equal, then we can say that the given quadrilateral is a parallelogram. If in a quadrilateral each pair of opposite angles is equal, then it is called a parallelogram. Next, if the diagonals of quadrilateral bisect each other, then it is a parallelogram. Next, quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. Now, we have to discuss about the theorems. Theorem number 1. The diagonal of a parallelogram divides it into two congruent triangles. This is a statement. Now data. Here statement is given in word language and we have to write in the mathematical language. So data is ABCD is a parallelogram, AC is a diagonal. To prove, diagonal AC divides parallelogram ABCD into two congruent triangles like triangle ABC congruent triangle ADC. This thing we have to prove. Figure you can see here ABCD is a parallelogram and AC is a diagonal. Proof. In triangle ABC and triangle ADC, BC parallel AD and AC is a transversal angle. So, angle BCA is equal to angle DAC, alternate interior angles. Angle BAC is equal to angle DCA, alternate interior angles. AC is equal to CA, this is a common. So, we can write triangle ABC congruent triangle ADC, ASA rule. Thus, diagonal AC divides parallelogram ABCD into two congruent triangles, triangle ABC and triangle ADC. Here, this first theorem we have to write with proof. Now, theorem 8.2. Now we have to theorem 8.2, 8.3, 8.4, 8.5, 8.6 and 8.7. We have to discuss only statement. Without proof, we have to use to solve the sum. Theorem 8.2. In parallelogram, opposite sides are equal. In parallelogram, opposite sides are equal. Theorem 8.3. If each pair of opposite sides of quadrilateral is equal, then it is a parallelogram. This is the converse theorem of 8.2. Now theorem 8.4. In parallelogram, opposite angles are equal. In parallelogram, opposite angles are equal. And in theorem 8.5, if in a quadrilateral, each pair of opposite angles is equal, then it is said that it is a parallelogram. This is a converse theorem of 8.4. Here, if in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Theorem 8.6. The diagonals of the parallelogram bisect each other. The diagonals of the parallelogram bisect each other. Here you see there are two diagonals in a parallelogram. Theorem 8.7. If the diagonals of the quadrilateral bisect each other, then it is a parallelogram. Theorem 8.8. A quadrilateral is a parallelogram if a pair of opposite sides is equal and parallel. A pair of opposite sides is equal and parallel. Then we can say that the given quadrilateral is a parallelogram. Now, till theorem 8.8, we discuss about the theorem where we use this theorem directly in the solution of the sum. And now, theorem 8.9, we have to write with proof. The statement of theorem 8.9, the line segment joining the midpoints of two sides of the triangle is parallel to the third side. This is a statement. Data. In triangle ABC, E and F are the midpoints of AB and AC respectively. To prove, first EF parallel BC and EF is equal to 1/2 BC. Construction. D produce a line segment ED to D, which ED parallel BC and EF is equal to FD. Join CD, which AB parallel CD and AE is equal to EB is equal to CD. Figure you can see here. Now proof. In triangle AEF and triangle CDF, EF is equal to FD by construction. F is equal to FC. F is the midpoint of AC. Angle AFE is equal to angle CFD, vertically opposite angles. So we can say that triangle AEF congruent triangle CDF by SAS rule, side angle side rule. Now we can write AE is equal to CD by CPCT and angle AEF is equal to angle CDF also by CPCT. This is number 1. AE is equal to CD number 1 and angle AEF is equal to angle CDF. This is number 2. Now from 1, A is equal to CD and AE is equal to EB is given. So we can write CD is equal to EB. This is number 3. Again from 2, since ED intersects AE and CD at E and D respectively, making equal alternate interior angles so that angle AEF is equal to angle CDF. This is number 4. AE parallel CD. From 3 and 5, EBCD is a parallelogram. Hence, ED parallel BC and ED is equal to BC. But EFD are collinear points. So, EF is equal to FD by construction. Thus, we can say that EF parallel BC and EF is equal to 1/2 BC. Here, the proof is completed. Now, theorem 8.10. The line drawn through the midpoint of the one side of a triangle parallel to the another side, I'd bisect the third side. This is the theorem 8.10.